Very good. Thank you. So Avi sent me an email. I know sorry I wasn't here yesterday. But would you be willing to discuss Paul Rummer's paper? I went into prediction mode. What was the probability of paper? Almost zero. What was the probability of slides? But I was here last year, but then was it going to be interesting? That I thought was pretty high. Would I have anything to say? And I was very diffuse prior. And then I remembered what Danny Kahneman said last year, wisdom is breath. And so I decided to embrace this. Almost all my predictions have come true. So it goes. Okay, what did Paul say? I thought maybe, I actually think there's two things that Paul is trying to tell us here, and they're both, I think, imperfect vessels for each other, though they're both quite interesting. One is taking quite seriously, and I think Paul has tried to advocate this to many of us for a long time in a way that I don't think people have appreciated, is really thinking about how big systems level changes are made in society, about how knowledge is produced, accumulated, embedded into institutions that we now take for granted. Think of like the high school movement or something like that. There's some people who kind of play around with something like a toy model. There is something like a wind tunnel. There's something like test flights. And there's something like observational field data where we sort of say, how does our overall, how is Obamacare doing relative to, whatever else you might want. In the human learning field, and I actually would broaden this to saying in a lot of fields, but for sure in human learning, there seems to be relative to, I do spend some amount of time teaching and collaborating with engineers. They always get surprised that like we miss the part where they're, kind of a wind tunnel. We just don't have as much of that as you would think in areas like improvements in education. And so there's tremendous numbers of theory. Paul might have one theory of education. I might have another theory. We might have different toy models. We might, in fact, have a lot of mini-sized test flights, but we don't have a lot of wind tunnels. And so the proposal here is that if this is a general purpose invention for the method of invention, if that's what what we're calling AI or machine learning is, that in principle can be the wind tunnel for human learning. Okay, that is a big part of, I think, what Paul's saying. Then the other thing he's saying is spelling reform. Okay, and you sort of have to go with that as the example. And I'll come back to that, though there's a case of saying you can take on spelling reform as a meaningful and separate thing, and I'll come back to that in a number of seconds. I do think that what's the key insight here is that, right, you would think that given what people say, particularly I think Paul comes at this as somebody who knows about machine learning but isn't, deep in, kind of doing a lasso regression on the side. What he's heard from this audience and others, both computer science as well as economists, is that this has dramatically improved our ability to create iterated systems against small sample data sets with training samples and tests. And it's difficult to test alternative human learning populations and alternative orthographies. Orthographies is like I before E except after C, except in the many cases when it's not true. Like that rule list is part of our orthography. And you could have something like a Netflix prize for spelling systems. Boy, wouldn't that let us sort of at least try out alternative spelling systems if you decide that's your priority. And so here's Paul's proposal. Kind of, I think it might be helpful to kind of think of it as a bit of a cycle, so on and so forth. Okay, what am I going to talk about? I have like 6 minutes? Yeah. Okay. I'm going to talk a little bit about wind tunnels, because that was the only term I knew something about when I got the title. Then I'm going to talk about wind tunnels in human learning, spelling reform, and the nature of machine learning. So wind tunnels, I actually think there's something incredibly important to think about in terms of wind tunnels. And this is, I have to say, drawn from being an RA for Nate Rosenberg many, many years ago. But it's quite interesting. That is, in fact, the Wright brothers wind tunnel. It was pretty small. People, as soon as they started saying we could do heavier than air flight in the 1850s and 1860s, they immediately understood that the first thing you'd need to do is build something that would allow you to simulate the motion of a fluid, air, across a vessel. They tried that. There was this guy, Otto Lilienthal. The Wright brothers basically took his book of measurements, which is often how we use wind tunnels. It creates engineering parameters, and he wrote it in German. That was not actually the problem. The reason none of you have ever heard of Otto Lilienthal, even though he was the by far best aviator of the 19th century, was that in 1896, well, his experiment kind of failed while he was in the air. Kind of an Uber kind of problem there. He died, okay? So all we had was engineering estimates. The Wright brothers spent 2 full years, as did much of the rest of the world at that time that was trying to solve aviation, particularly after the invention of the internal combustion engine, was once you had, but they basically decided, and that was actually their key idiosyncratic insight, was they decided to keep the idea of a wind tunnel, but throw away the book. And they built their own wind tunnel. They produced their own measurements that were at a tremendously, they were by far leapfrogged over everybody else. And that allowed them to very quickly in the fall of 1901 build their own wind tunnel and literally run 300, 400 experiments in the course of 6 months. And it was that, they then go back to Kitty Hawk, and basically they have a perfect glider. And as anyone who has spent any time at my house can tell you, we have the key step in designing a good airplane is first designing a perfect glider. That was the key distinction that the Wright brothers fully understood and that distinguished them from the rest of the field, including here in Canada, Alexander Graham Bell, who just thought if you just put more weight, it would just lift itself. Okay, so it goes. A wind tunnel actually requires a very specific things. In those areas of science and engineering where we have quote unquote wind tunnels, it requires an interplay between basically a really keen understanding of the underlying scientific basis of the physical properties you're trying to express, as well as a linking mechanism between that and the ability to prototype. So if you think about areas like chemical engineering, if you think about clean rooms and how you do sort of kind of simulation that allow you to mimic clean room activity in the context of semiconductor production, those are the places where it works. And it's not clear why and when it does not work in the area of social science. And so I just want to sort of hit on that as, that wasn't the main part of what Paul talked about, but that's, I think, the centerpiece of what you're talking about, and how does machine learning relate to that? Why is there no wind tunnel for human learning? I think I can tell you that, is that by and large, the program evaluation literature in education is not quite run by economists, but it's kind of run by economists. And we've got a pretty simple theory. Here we could have other people, but somewhere between Becker, Mincer, and kind of, the revolution of which Carolyn Minter-Huxby, Carolyn Huxby is both a part as well as a leader, has a kind of pretty simple theory of education. You go to school. Maybe the school's in a more competitive district. Maybe it has better or worse incentives for the teachers, and you get more education, and that leads to a higher productivity and wage. If you go to the learning literature, this is like their theory of the collection of learning theories. It's endless, and there's no moment of agreement. And this group basically doesn't talk to this group. So I would say that there's just too far a gap right now scientifically between those two perspectives, the kind of what works perspective and the underlying theory of learning. Okay. The second part is spelling reform. So now, okay, Paul is exactly correct. Spelling reform has been around for a while. Interestingly, spelling reform is actually quite common, right? So just to be clear, in your lifetime, the Germans went through spelling reform. Like, they changed their alphabet, right? It was called the Reich something something Bung. Don't know what that is. Teddy Roosevelt, I will say I learned more about spelling reform in the last 24 hours than you could ever imagine. I did learn about the great vowel shift for your reading pleasure. I would say one thing. I kind of read through some of the links that Paul gave me, as well as my own perusing of the internet. I'm not sure. I think Paul is a little bit overstating. I don't think even the people who advocate spelling reform think that you get first-order improvements in the kind of productivity or sort of advantages that we tend to look at as economists or as policymakers through spelling reform. In fact, spelling reform is a lot about power and culture, right? So if you are the Finns and you like if you're currently like the Denmark, if you like Denmark, and right, you're going to explain this to me, Eric, right? Right? If you explain when you're on the side of Denmark, then you have the Danish alphabet, or you don't, right? A big part of Teddy Roosevelt's expulsion of the King's English was, American exceptionalism, right? As was Andrew Carnegie. Okay. Third part. Okay, so I have like 90 seconds. Okay. The third part is which I do think is even if you accepted that we should do this, is machine learning the solution here? And so I think that there's a piece that I think relates to a bunch of different papers. I was talking about it with a few people during lunch. Key part is what can be additionally predicted from machine learning over linear models. And basically, that's a complicated question, but I think that it's really important to get that the thing that prediction from the kind of class of techniques that are coming out of AI deliver on is when there are a reasonably small and countable number of traceable paths that rely on subtle interaction effects that you couldn't see perhaps through your own observational intuition, but ex post you probably could. Okay, that's a little bit out there, right? So you can't predict the roll of a dice, and lots of things are highly predictable. Like residential electricity demand is predictable in a linear model at like 99%. Right? There's no additional explanatory power you could get, right? The consequence of that is when you think about something like language itself, the set of problems that you're thinking about are coordination issues. People have diverse beliefs about what matters. People have different interests. There are transition costs. And there is a need for local adaptation because different people will naturally evolve to talk about different things, and language is an evolving, we know humanly people evolve in how they speak. So in other words, I'm not sure that something that, we must take it this relative to Gans, Goldfarb, Agarwal, I probably did that in the wrong order, right? But if you take their thing, which is if you can get lower prediction, better prediction at lower cost, what do you get from that? I'm not sure if I get even a very lower, if I get much more evidence on the right way to spell in the Anglosphere, I don't see how I solve A, C, D, and E in a relatively natural way without some very compelling case that lead to a dramatic improvement or that somebody with a very significant economic and political interest wanted to make it so. Those are my thoughts.
Okay. Thank you.
Thank you.
Thank you for that.